Are you guys sick of exponents yet? How could you be sick of exponents? Exponents are the best. They're like bread and butter. I'm gonna use them all the time. I know I use them in my everyday life, so obviously everybody does, right? Hello and welcome to another Math Monday. I'm gonna give you guys a little break from exponents today, so we're not really. That's my evil math face. I don't know why I do that. And we're going to talk about interest and interest rates. Oh my goodness, it's one of those things that's like useful that people actually want to learn about. Well, kind of, except for you don't. Except for then when you become an adult, you're like, oh, this is really important, so I should probably know about this. So there you go. That's what we're going to do. You ready? All right, so we're going to talk about interest and interest rates, i.e. exponential growth. See what I did there? Not getting rid of exponents. They're in everything. So instead of just giving you the formula, because what's the fun in that? I'm going to actually take you through how you would calculate interest, and then hopefully from there you can see why the formula is the way that it is. Because when you do that, you actually understand it's not just a bunch of letters on a piece of paper. So just to make it really nice and easy, let's say that you have $100 and you're investing it at 10% per year. So that means you're adding 10% of 100. That's the original 100% of the investment to 100. So what's 10% of 100? It's $10, right? So then you're adding 10 to $100. But what that really means is that the amount after each compounding period is going to be worth 110% of its previous amount. If you want to figure out more about percents and how those work, I do have a video, I think it's Math Monday 4 or 5, about percents. So you should go watch that if you're having trouble with how percents work. After 1 year, we know that we have the $100 and then we're getting 110% of that. That's 1.10. So that's what we do to get $110. We multiply it by 1.10. So what would you do for the second year? Well, now instead of just adding $10 every time, because that's 10% of the original amount, and that's not how interest works. Okay, that would be linear growth if you're just adding $10 every year. Now we want 10% of the new amount, and that's how interest works. Okay, we get 10% of the new amount. So now I need 10% of $110, and I add that. So what we're going to do is we can take our original amount that we invested, $100, and then we multiplied it by 1.10 to get how much we had after 1 year. And then guess what we're going to do again? Multiply by 1.10. So I'm multiplying by 1.10 twice. Does anybody see what's happening there? That gets me $121. And really, if we're multiplying by 1.10 twice, that just means we're raising it to the power of 2 exponential growth. You see it? So let's do it once more. Say after 3 years, well, we had our original $100, and then we multiplied it by 1.10 after the first year, and 1.10 after again to get the second year, and 1.10 again to get the third year. So I'm multiplying by 1.10 3 times. Exponential growth. I got $133.10. So really, if I want to shortcut that, I could just take $100 multiplied by 1.10 to the power of 3. You see what's happening with those exponents? Kind of looks like they match up with the number of years that this thing is being compounded. So that's how we're going to get our formula, because really the amount of money that you have after n years is just $100 times 1.10 to the power of however many years you have. We'll call that n. Okay? So that brings us to our general formula, and that's this. A is equal to P times 1 plus I to the power of n. You're going, wait, now that just looks like letters on a page again. So let's think about what each of those letters would represent, comparing it to what we had above. A, that's the amount that we're going to get at the end of however many years. P, that's what we call the principal, so that's the original amount, right? Because that is where the $100 would go. The 1 is just a 1 because what we need to do is we need to add the interest rate to 1 to get how much you'd have of the original amount plus the added interest. So I is your interest rate, but in decimal form, not percentage form. Remember that. And then we have to the power of n. N is the number, well, so far it's been the number of years, but now I'm actually going to change that. It's not necessarily the number of years, it's the number of compounding periods. The reason I'm saying that is because you can get interest rates that don't compound every year, meaning they don't add that 10% or that whatever percent every year, but there could be a bunch of different things. So let's go over those. What are the different rates that you can invest at? So we have annually, and that's what we would call once a year. So that's when your interest rate is just whatever your interest rate is. We have semi-annually, and that's when it compounds it twice a year. But what you need to do is you actually need to take the interest rate that it gives you and divide it by 2. But then it's still compounding it twice a year. So say at the 10% per year, if it's really compounding twice a year or semi-annually, it's going to be doing 5% but twice in 1 year. We could do quarterly, that's 4 times a year, so that'd be every 3 months. And so you're going to take your interest rate and divide it by 4 for that. We have monthly, that's every month, so that's 12 times a year, obviously. And that's going to be your interest rate divided by 12. You could do weekly, that's 52 times a year. Take your interest rate divided by 52. You can even do bi-weekly, that's 104 times a year. You take your interest rate divided by 104. And I don't know that this ever happens, but hey, let's go for it. You could even invest daily, where it compounds daily. So that's 365 times a year. So you take whatever that interest rate is and you divide by 365. And that's how interest rates work and how compounding periods work. So let's just go over one example, make sure we're all on the same page and we do get this. So say you actually have $500 and you're investing that, an investment at a rate of 4% per annum. So you see that 4% per A or that /A, that means per annum. So that's 4% per year. That's all that's meaning. But you're going to invest it quarterly. So what does that mean? 4 times a year, every 3 months. So I want to know how much the investment's going to be worth in 5 years. Okay? So let's go back to my formula that I had. A is equal to P times 1 plus I to the power of N. Okay, so that's the amount in 5 years. Remember, P is our principal investment, so that's the original amount you're investing. That's $500. I'm going to multiply that by 1 plus the interest rate. So interest rate is 4%, that's 0.04, but remember, we're dividing that by 4 because it's quarterly, right? And then we're going to put that to the power of, well, we have 5 years, but then again, it's being compounded quarterly, so 4 times every year. Okay, so we're going to go 5 times 4, because for 5 years, it's 4 times each year. So what does that get us? That gets us 500 times 1 plus 0.01, because that's 0.04 divided by 4, to the power of 20. I don't feel like writing it right now, because I'm also just running out of room. But if you want to, you can write the 1 plus 0.01 as 1.01, because that's what that is together. And that's what I'm going to put into my calculator, as you can see. And so what do we get? $610.10. There you go. And that's how you figure out how much is invested. So I gave you something real world, something really practical to figure out how you can do different investments and what they mean. It's actually better to always have more compounding periods. It's weird because you think, oh, but I'm having less of a percentage, but actually more compounding periods is going to be better for you. And we're gonna go over more about that next week, so I can tell you about one of the most exciting numbers in mathematics. Yes, this was all a ruse. I'm trying to get you to listen to practical math so I can just talk about my nerdy stuff. And I'm so excited. So, here's my question to you. Do you know what number I'm talking about? It's irrational. It's not pi. If you think you know, comment below. Have a great week, guys. I'll see you next week.